what we have here is perspiration, aka or sweating, as you probably know it. So there are two main types of perspiration. We have the insensible perspiration and the sensible perspiration. So sensible perspiration is like when you're sweating and maybe you're exercising or you're outside and it's like 90 something degrees, and those are the beads of sweat that you can feel trickling down your forehead or your face or body. But insensible perspiration, you're always sweating to some extent, but such a tiny amount that you can't really feel it with all the nerve endings in your skin. But they're all perspiration. So again, this insensible is the one you don't notice, but you're kind of always doing in the background. Sensible is when you feel that sweat rolling down. And what causes that perspiration? It all deals with these glands, and there are many types of glands. I'm going to cover general categories in this last lecture before the exam. So we have excretion and glands. So eccrine or merocrine sweat glands. So we did cover in the tissues about different types, like what merocrine means. But eccrine sweat glands are located almost everywhere. So a nice mnemonic I was taught was like eccrine is everywhere. So it's almost everywhere, but practically everywhere. So you have where their skin, except for very few places, you have eccrine glands. And what are they doing is secreting this watery secretion, and it does have some salt as well. So why is sweat salty? It's due to these sweat glands and this watery secretion. But the thing about sweat being salty is not just providing flavor. It's also due to osmosis, because what happens if you put a very salty solution outside of a cell? Well, that's going to draw water out, right? So if your eccrine sweat glands are secreting something that's salty, that's going to draw water outside of your body. But what about that water outside of your body? What is it going to do to the heat of your body? Well, that water is going to absorb heat, and it's going to cool yourself off. Because this is why these are very important in thermal regulation, especially in hot environments, because if you bring more water to the surface of your body, that allows it to absorb heat, and when it evaporates, that heat evaporates with the water as well. Let's see, if there's a 9:30 live stream plan for this morning, that might be a YouTube thing. So there's class time is 1:30 to 2:30. I mean 1:30 to 2:20. So whatever that was, no, class isn't at 9:30. Okay, so that whatever you saw on YouTube, it's always, unless all the live streams are 1:30 to 2:20 unless it's an exam day, or starting next week, this is when like the med students start their second unit that I'm co-director of. So this is where sometimes I have to do something at the medical school, and it does overlap with the class time. I will pre-record that, but I'll also let you know in advance when I'm doing that. So that's what we have there. Okay, so apocrine sweat glands. So this is another type of sweat gland, but instead of being watery like those eccrine or merocrine sweat glands, they produce the sticky and cloudy secretion. And actually what makes it sticky and cloudy is all these fats and oils and lipophilic compounds. So what we have is that secretions, and actually proteins as well. So the secretions break down, and if you ever if you ever tasted like cooking oil or butter or lipids, and then it starts to rancid, you may be like, this tastes a little old and kind of tastes funky. Well, same with lipids. When they're broken down with bacteria, they can often form smelly compounds. And what happens is that these apocrine sweat glands, we all have them, but it's only after we undergo the changes that are associated with puberty that these become active. So, little kids can be smelly, but like once we're teens and older, we have a different type of smell, as due to these apocrine sweat glands. And where do you find them? Well, unlike the eccrine sweat glands where you find almost everywhere, apocrine sweat glands are found in specific areas. And not throwing my fellow guys underneath the bus, but I love this meme, not because it's funny, but it's because it actually shows you, okay, where are the oiliest and smelliest parts in our body? And I like it because it's like, okay, this is where we find apocrine sweat glands. We find them in the armpits, we find them in the groin. And just for the completion's sake, let's add the nipples to this diagram over here. So I like this diagram because it shows us or typically the smelliest parts are the parts we really have to wash thoroughly with soap in order to not get smelly. And it's these parts right here, and what's causing that? Those apocrine sweat glands that are broken down by bacteria into these smelly compounds. But maybe some people don't wash that part, but yeah, so that's so Eccrine, that's the one that secretes the watery secretion and very important in regulating our body temperature. But apocrine, that's the one that's important in secreting those very waxy and or just those smelly compounds and those sticky substances. Okay, let's talk about another special type of glands called sebaceous glands. So sebaceous glands, these are connected to the hair follicles, and this is a hair follicle over here. And what we have are these sebaceous glands that are right here. So this isn't where the hair root is, but it's connected to that whole part apparatus over here. And what they do is that as the hair grows, they secrete oils that help to lubricate and condition the hairs in our skin. Now, sebaceous filaments. So what happens if you allow sebum? So they secrete this substance called sebum that's oily and waxy. Now, what happens if the sebaceous filaments or the sebum builds up in this hair shaft, along the hair shaft and root? Well, you might get something like this. But I love this clip because look at that when he pulls it out. You can see that little hole, that little crater. So that was a pocket where that sebaceous filament was. So that thing he pulled out, that oily, that yellowish, waxy looking thing, that is a plug of semen, or plug of sebum. Big difference. Yeah, so that's a plug of sebum. So sebaceous filaments, that's what we have there. So yeah, I love this one because they have the plug right there. I know if you like Dr. Pimple Popper, I love these videos. Like, oh, I love that one, even though it's kind of gross. It shows that little crater. It's like so perfect. I don't like the ones where people pop as like oozy and weepy, but yeah, that's kind of gross. Okay, so what we have here, so sebaceous glands, sebaceous gland, what the hell is that? I have to use another one, but yeah, so what we have here is like so what we have here is that all the sebum is building up, and then we have over here is that, okay, now the sebum is building up, but instead of forming a filament, this is kind of trapped by that pore where the hair shaft is exiting, right? So what happens if these sebaceous glands remain plugged? Well, notice that this is becoming raised and it's pushing up the epidermis. And if it starts attracting a lot of like inflammation and blood to the area, this is what we might see with acne. So this is something that can result from these sebaceous glands. And if you're producing all the sebum, and instead of the sebum going out to the surface and providing oils for the hair and the surface of your skin, this is why we can encounter this what we call comedo in dermatology. But if you think that's fascinating, like, I mean, yeah, that one's pretty chunky. So I don't like the one where it's like weepy and it has all this, like, it might be infected with bacteria. That one it's just like glandular secretions. But what we have here are sebaceous glands. But what happens if this sebum builds up, but there's no eruption of that sebum out past the epidermis? Well, this is what we might have with the epidermoid cyst. Or sometimes we call, or in this case is when it develops from a sebum gland. That's what we call a sebaceous cyst. And so what she did is actually cut this layer, and this is what she was squeezing out. She was squeezing out all that trapped sebum. And if you ever smelled like or just remember like my previous example, how when butter or lipids or oils or frying oils get rancid, they kind of taste funky. They also smell funky too. So this is why if you've ever seen some like sebaceous cyst lance or had one lance, then it kind of like has that smell. That's due to all those oils and waxes. Or another example, like grease traps if you ever worked in the food industry, like grease traps have this unholy smell, and it's due to the bacteria breaking down those compounds, especially fatty ones. Same with sebaceous cysts. So oils, when they get broken down by bacteria, they tend to smell pretty bad. Yeah. So why do hairs need sebum? Again, that waxes and oils. It's your body's natural conditioner, but if it builds up too much, it can result in things like the acne we saw and the sebaceous cysts.